Hi there. This video is an exam paper walkthrough of the Eduqas GCSE Mathematics Higher Tier Component 2 paper from autumn 2023. This paper is worth 120 marks in total, and this is the second video of 6. It will focus on questions 5 to 8, which account for 25 of these marks. Eduqas Component 2 papers are calculator papers, so a calculator should be used. A little disclaimer: there may be more than one way to answer a question. The methods shown in this video are not the only way some mathematical skills can be applied. Okay, let's get started. 5a. Expand and simplify x add 3 multiplied by x add 7. So there's several different ways you can expand double brackets. I'm just going to use arrows to make sure that everything in this bracket gets multiplied by everything in this bracket. So I'm going to start with this x and I'm going to multiply it by the other x. So x multiplied by x gives me x squared. I'm now going to multiply this x by the 7. So x multiplied by positive 7 is positive 7x. So now I've dealt with that x, I'm going to deal with the 3. So positive 3 multiplied by x is positive 3x, and then positive 3 multiplied by 7 is positive 21. So that's going to get me 1 mark for any 3 of those being correct, guys. But it says expand and simplify, so I need to collect like terms for these x terms. So we have x squared, but then we have 7x add 3x. So we have 10x in total with plus 21 on the end there for full 2 marks. Part B, solve 7x add 6 equals 4x add 7. So I'm just going to write this here so I can organise myself because I like to keep things aligned. So we have the unknown variable that we're solving for, x, on both sides. So the first thing we need to do is eliminate, get rid of the smallest lot of x. Now the smallest lot of x is 4x. 7x is bigger than 4x. This is a positive 4x. I know it's positive because there's no negative sign in front of it. So the inverse would be to subtract it. So when I subtract 4x from 7x, that leaves me with 3x. I've done nothing to the 6, so that stays there. And then I need to subtract 4x from the right-hand side to balance the equation. 4x subtract 4x is what cancels that out for me, guys. And then I'm just left with that positive 7. Now I've got a 2-step equation. And what I'm going to do now is eliminate the add 6. Because what I'm aiming to do is isolate the x term and then solve for x. The inverse of adding 6 would be to subtract 6. So 3x, I've done nothing to the x term here, I'm dealing with numbers only. 6 subtract 6 is what cancels it out. And then when I subtract 6 from the right hand side to balance the equation, 7 subtract 6 is 1. Now we have a 1-step equation. 3x is 3 multiplied by x. I'm aiming to isolate x on its own. So the inverse of multiplying by 3 would be to divide by 3. So when I divide 3x by 3, I get x. I need to do the same to the right-hand side. 1 divided by 3. Be really careful here. It's a common mistake. Write it as a fraction. 1 divided by 3 and leave it like that, guys. Some people make the mistake of reversing that and doing 3 divided by 1. That's not what you're doing. You're doing 1 divided by 3. So leave it as a fraction. Part C, factorise y squared subtract 400. So when we're factorising, we're putting brackets in. So it's the opposite of expanding brackets. Now this is a quadratic, and so we're going to have to factorise into 2 brackets. I know it's 2 brackets because I have a squared term and the number term. Both of those things mean that I need 2 brackets. Now each of these brackets needs to have a y in it, because that's the only way I'm going to make y squared when it gets expanded, okay? This is an example of the difference of 2 squares, so the number that goes inside the bracket is the square root of 400. So the square root of 400 is 20, so I need plus 20 here and negative 20 there. Part D. Solve the following simultaneous equations. You must show all of your working out. Okay, so the first thing when I'm solving simultaneous equations is I need to see if the coefficient of any of the variables match. So I've got 7x and 1x, that doesn't match. I've got negative 3y and positive y, they don't match. But I am going to make my y's match. So I'm going to multiply this equation by 3. When I'm multiplying this equation by 3, everything gets multiplied by 3. So x times 3 becomes 3x. Y times 3 becomes plus 3y, and then 3 times 3 becomes 9. So I've scaled up that equation, and then I'm just going to write this one above it for ease. So now you can see that actually the coefficients of my y do match. They're both 3. Doesn't matter that they're different signs, but what matters is that they match. So now it's those signs that I'm going to look at to decide whether I add or subtract these equations, because I'm trying to eliminate one of those variables. So when I look at this, I have a negative and a positive. So to eliminate the y's, the variable that I've made match in terms of their coefficient, I need to add these equations together, because negative 3y, add 3y is going to eliminate it and make 0. So the signs are different, we're adding. So 7x add 3x is 10x. 26 add 9 is 35. Now we've got a one-step equation that we can work with to solve for x. So 10x is 10 multiplied by x. The inverse of multiplying by 10 would be to divide by 10. 10x divided by 10 is x. We have to do the same on the other side, remember, to balance the equation. 35 divided by 10. I know that's 3.5, but if you weren't sure, that's what your calculator's for, guys. So I know that the x value is 3.5, so I'm going to write that straight away on my answer line, making sure my decimal point is nice and clear. Now that I know what my x value is, I can substitute it back into one of the original equations to find my y value. So I'm going to use this equation because it looks like the simplest of the two. So if x plus y equals 3, and I know x is 3.5, I'm going to replace that x with 3.5. So 3.5 plus y is equal to 3. So now I'm solving for y. So what I'm going to do to solve for y is eliminate this 3.5 because I want to isolate the y on its own. So this is a positive 3.5. I know it's a positive 3.5 because there's no negative sign in front of it. So to eliminate it, I need to do the opposite, which would be to take it away. So when I subtract 3.5 from the left-hand side, it just leaves me with y. But remember, we have to do the same to the other side. 3 subtract 3.5. I know that that's negative 0.5. If you didn't know that, guys, calculator. So negative 0.5 is my y value. Question 6. The two shapes below are similar. So we've got these two shapes with some dimensions labelled. The diagrams are not drawn to scale, so we can't measure anything directly from them. Find the value of r and find the value of t. So we have r and t here, and we need to find their values. So when we're working with similar shapes, we're working with scale factors. Now, the only information here I've got are lengths, so I'm not dealing with area or volume, I'm working with the length scale factor. So to work out the scale factor, we find the proportional relationship between the larger shape and the smaller shape. So what we need to do is find corresponding sides on the shape that we have the information for. So I know that this side of the shape is 15.6. It corresponds to this side of the smaller shape, which is 10.4. So my scale factor is 15.6 divided by 10.4. We're going to stick that in our calculator. So that tells me that my scale factor is 3/2, or if you're more comfortable working in decimals, my scale factor is 1.5. So the bigger shape is 1.5 times bigger than the smaller shape is 1.5 times smaller than the bigger. And we can use this scale factor now to find our missing lengths. So we're going to start by finding r. So if you look here, r on the bigger shape, this side here corresponds with this side here. So r has a relationship with 7.6 on the smaller shape. So we know the smaller value, we're trying to find the bigger value. So to go from the smaller shape to the bigger shape, we multiply this length by our scale factor. So R is equal to 7.6 multiplied by our scale factor of 1.5. So R is 11.4 centimetres. So I'm just going to put 11.4 centimetres on the line at the bottom there. Now we're going to find T. Okay, so T, this length here, corresponds to 19.5 on the bigger shape. So this time we're going from a known bigger value to its corresponding smaller value. So instead of multiplying, we're going to divide because we want it to get smaller. So we're going to do the 19.5 divided by our scale factor of 1.5. So 19.5 divided by 1.5 equals 13 centimetres. So T is 13 centimetres. Question 7. Vaughan cycles down a track from the top of the mountain to the bottom. The track goes down at an angle of 48 degrees to the horizontal. Vaughan is 800 feet above ground level. So we have a diagram here of the mountain, and Vaughan's here is going to cycle from the top to the bottom. This is our 48 degree angle to the horizontal, and this is how high up he is at the top of the mountain, 800 feet. The diagram's not drawn to scale, so we can't measure anything directly from it. Part A. Vaughan cycles from the top of the track to the bottom of the track. What distance has he cycled? So what we need to recognise here is the journey from the top of the track to the bottom of the track actually forms the hypotenuse of a right-angled triangle. They've nicely marked the right angle there for us, guys. So we are going to be working with trigonometry because we've got other angles that we know and we're trying to find the hypotenuse. So this right-angled triangle, opposite the right angle is the hypotenuse. We don't have another angle marked inside the triangle, but we can calculate this angle because the horizontal forms a 90 degree angle with the side of the mountain there. So if we do 90 subtract 48, which equals 42, we know that that angle there is 42 degrees. Then we can continue to label our triangle. The side opposite the other known angle is the opposite, which means this must be the adjacent. Now, when we're working with trigonometry, we need to identify the sides that we are interested in. So we are trying to find this length here, okay? So we're looking for the hypotenuse. We want to know the distance that he cycled, but we also know the adjacent because they've told us he's 800 feet above ground level. So we're working with the adjacent and the hypotenuse. So this is the cosine ratio. So cosine is equal to the adjacent over the hypotenuse. You may also see it like this in a formula triangle if you're used to seeing SOHCAHTOA in that way. So what I'm going to do is substitute in what I know now. So the cosine goes with the other known angle. So we're dealing with the cosine of 42 is equal to the adjacent, which is 800 feet, divided by the hypotenuse. The hypotenuse is what we're looking for. Now you've got two options here. You can go the algebraic method because you know how to rearrange that to solve for h, or you can use your formula triangle. So h is what we're looking for. So if I cover up h in the formula triangle, a divided by c. So I'm doing, our value h is the adjacent divided by cos 42. So h is equal to 800 divided by cos 42. Always close that bracket just to be safe as habit. And then we're going to write down here. So 1076.5 is what I'm going to write. So the distance he cycled, they don't tell us to round it in any particular way. So I'm just going to round it to the nearest foot, maybe. In fact, no, I'll just write that on mental line. 1076.5 feet. They don't tell us to round it, so I'm not really going to. Part B, state an assumption you have made in answering part A. Okay, so this is something you've assumed when we formed that right angle triangle to find that distance. Well, if you look at this diagram, this line's a little bit shaky, it's a little bit wobbly. We've assumed it's a straight line. So we've assumed the slope is smooth and not bumpy, because if it was bumpy or if it veered off like a normal cycle track could, he potentially would have cycled further. So I'm just going to put, have assumed he rode in a straight line and the road was smooth. So I'm assuming it was just a straight line down to the bottom of that mountain. The next part, if your assumption is not correct, what effect would this have on your answer to part A? Well, if this wasn't a straight line and he went off on a wiggly line or over bumps and things, sorry for the hand movement then that's going to have an effect on our answer, because he will have cycled further. It's not just one straight line to the bottom, he's potentially cycled further. So if my assumption is not correct, so I'm going to put, if the slope is not smooth, he will have cycled further. Question 8. Bjorn is a jewellery maker. So we've got a diagram here. This looks like potentially a silver bar with a special offer 5% discount. Part A, he pays £1,451.60 for a silver bar after a 5% discount has been applied. What was the original cost of a silver bar? So we want to know what it cost originally, because this is the price after 5% has been taken off. So I'm going to draw myself a proportion table. We know I like those if you've looked at any of my other videos. So this is the cost and this is the percentage. So the cost of £1,451.60, it's a 5% discount. So the original price was 100%, but then they've taken 5% off. So 100 take away 5 is 95. So that price is 95% of the original, because they've taken 5% off. It's after that discount. I want to know the original cost of the silver bar, so I want to know what 100% is. So I'm going to need to scale down and up in this proportion table to get to 100%. So because I've got a calculator, I'm going to make my life easy. I'm going to go to 1%. So to go to 1% from 95%, I divide by 95. I need to do the same to the other side of this table. So 1,451.6 divided by 95. I can do that because I've got a calculator, so I might as well. So that's £15.28 is 1%. We want 100%. So to go from 1% to 100%, we're going to scale up by multiplying by 100. Remember, we do the same to the other side. So 15.28 multiplied by 100 is £1,528. So the original cost was £1,528. Part B. The silver bar is in the shape of a cuboid and has the following dimensions. So we have length 8.1, width 7.3 and depth 4 centimetres. Bjorn melts down the silver bar and uses the silver to make 200 identical pieces of jewellery. The density of the silver is 10.49 grams per centimetres cubed. Calculate the mass of each piece of jewellery. Give your answer in grams. Okay, so we are dealing with density, mass, and we're going to be using volume because we're dealing with a cuboid. So you may have dealt with a formula triangle like this. Density is equal to mass divided by volume. So let's see what we know. We know what the density is. We're looking for the mass. We don't know the volume, but they've given us all the information we need to find the volume of this silver bar, which is a cuboid. So let's start by calculating the volume. So 8.1 multiplied by 7.3 multiplied by 4. Just check you've put the right things in the calculator. We make mistakes. I've done it on a previous video. We are only human. So 236.5 0.52. So that's in centimetres cubed because we're working in centimetres and that's volume. Now we're going to work out the mass. Now that we have the density and the volume, mass is density multiplied by the volume. Okay, so we're finding the mass, density multiplied by volume. So the mass is equal to our density of 10.49 multiplied by our volume of 236.52, sorry. Now, this is in grams per centimetres cubed. This is in centimetres cubed, so they match in terms of units, which is why we can simply just multiply them. I've still got the volume in my calculator, so I'm just going to multiply by the density, which is 2,481.0948. So the question asks us to calculate the mass of each piece of jewellery. He's going to make 200, so we need to divide our mass by 200. It's still in my calculator, which makes life easy. So that gives me 12.405474. Now it asks for our answer in grams. We are already working in grams because our density tells us that we're grams per centimetres cubed. Centimetres cubed is the volume, grams is the mass. So each piece of jewellery has a mass of this. You can write rounded however you feel appropriate on your answer line.